Hey guys, so today we're going to have a look at a couple of questions from the 2019 paper 2. I'm going to start with probability. So question 3C, and it says 3 people are chosen at random. What is the probability that exactly 2 of them have blue eyes? So in the previous parts of the question we were told someone that has blue eyes, the probability of someone having blue eyes is 0.7, which means that the probability of someone not having blue eyes is 0.3. Remember, all probabilities add up to 1. So if the chances of you having blue eyes is 0.7, then the opposite of that is you not having blue eyes, which is 0.3. So there's a load of different ways of doing this. I think the easiest is probably just to list out all the possible ways in which this can happen and figure out the probability of those. So it says probability that exactly 2 of 3 people have blue eyes. Well, that's blue, blue, and not blue. Pick 3 people, blue, blue, not blue. Or we could have the first person with blue eyes, the second person might not, but the third person might have blue eyes. Or the first person doesn't have blue eyes, but the next 2 do. So what we have there is a situation where in each of these 3 scenarios, 2 people have blue eyes and the other person doesn't. So I can work out the probability of this, this, and this and add them together, but the probability of this is going to be the same as the probability of this and the same as this. So it's probably easier just to work out 1 and then to times it by 3, because there's 3 different options there. So let's work out the first one. Blue eyes, not blue eyes. So the probability of the first person having blue eyes is 0.7. And I times that by the second person having blue eyes, which is again 0.7. And I times it by the third person not having blue eyes, which is 0.3. And then what I got to do is I got to, because this is probably of only one situation, I've got to times that by 3. Because there's 3 different scenarios there. Okay? There's this, and this. And when I do that, I get 0.441. So the probability of 2 people having blue eyes is 0.441. The other option would be to find out the probability of exactly 3 people not having blue eyes, or the probability of exactly 1 person not having blue eyes, and then take them away from 1. But it's a little bit more complicated than that. So let's have a little look at question 5. So question 5 has got to do with area and perimeter of a circle. So it gives you this little diagram here. And it says, to begin with, find the area of this crescent here. So the crescent is shaded in a bit. It's kind of like a moon shape. And what we got to realize is that this is actually 2 circles. This is a big outer circle and a small inner circle. So I'm going to call the big circle C1 and the small circle C2, just so we have some reference points. It gives us the radius of both of these circles. So it tells us the radius of the big circle is 3. So the radius here is 3. It tells us that the radius of the small circle, right, is 2.5. Now, in order to find out the area of this, what we need to do is we need to find out the area of the big circle and take away the area of the small circle. So imagine you had that as a cutout, and then you took a scissors and you cut all the way around here. The area is what you're left with. So area of a circle, the formula is given to you in the exam. You might already remember it from your junior cert, so it's pi r squared. One of the most popular formulas. Or being the radius. So let's have a little look. Let's figure out the area of the first circle. So C1, well, it's pi. The radius in this case is 3. And we squared. Put it into your calculator, you get 9 pi. Now it's up to you. You can keep it in terms of pi. We're going to change it to decimals later, or you can change it to a decimal straight away. I'm going to keep it in terms of pi here. But if you press SD, you'll change it to a decimal, you get something in the region of 27. That's fine. The area of circle 2, well, pi times by 2.5 squared. So if you look there, circle 2 is the smaller circle, the radius is 2.5, and when we put that in, we get 6.25 pi. Again, if you wish, you can change it to a decimal, but obviously you don't have to, it doesn't make a difference at this stage. Now, to find the present, we take these two away from each other. So we do 9 pi pi gives us 2.75 pi. And now we're going to change it. So you just press SD in your calculator. So if you change that to a decimal, you get 8.64 centimeters squared. And that's how you work out the area. Second one I'm asking for is the perimeter. Now the perimeter is just the circumference of the crescent here. So imagine we walked all the way around it. So if we pick this point here, we'd have to walk all the way around here. Remember, it's still a second inner track we'd have to walk around as well. So we'd have to walk all the way around all of the outside. So what we're going to do, because it's two circles attached to each other, we're going to figure out the circumference or the perimeter of the first circle and then the second circle, and we'll add them together. A little bit tricky that. So perimeter, as I said, is called the circumference on a circle, and you might remember this from your unit circuit formula, is 2 pi r. Again, given to you in the exam in your table book, or being the radius. So let's find out the perimeter of the first circle. Well, the perimeter of the first circle is just 2 pi for your radius in this case, which is 3. And you get 6 pi. Change to a decimal if you want, you don't have to. The perimeter for the second circle, again, is 2 pi 2.5. Remember your radius is 2.5, which is 5 pi. So I've got 6 pi and I've got 5 pi. Now, 6 pi being the outside, 5 pi being the inside. And what I'm going to do is I'm going to add them together, because I have to walk around both of them. And that gives me 11 pi. And if I press SD on my calculator, that will change that to a decimal, and I get 34.56.